Aluminium foil has been a kitchen standard for longer than we can remember. It's a perfect cooking tool because it's an ideal heat conductor. From the roast in the oven to the freezer, it has a myriad of uses. But how does a huge block of solid aluminium get transformed into a paper-thin sheet of foil? The manufacture of aluminium foil requires the repeated thinning out of a large block of aluminium. This massive ingot's journey begins by being blasted in a natural gas furnace. It takes 3 to 8 hours to melt this 27,000 kilo lump of aluminium. The remelting furnace operates at a staggering 750 degrees centigrade. No chances are taken, because the fusion temperature of aluminium is 660 degrees centigrade. A portion of aluminium is poured into this small mould to make a sample. Solidifying in just seconds, the sample allows for testing to verify the contents of the prepared alloy. The next encounter takes the now liquid aluminium through a trough to the tapping well. Any impurities are filtered out in special receptacles. Poured into ingot moulds, water accelerates the cooling process. The molten aluminium is quenched and the ingots solidify. Now the heavy machinery gets to work. Each ingot is massive, measuring 4.4 meters in length. It weighs a whopping 7,500 kilos, so it has to be handled by overhead cranes and placed on special plates. With absolute precision, the crust-removing machine skims 3 millimeters of the ingot's thickness. In doing this, impurities are eliminated to achieve a perfect mirror finish. All traces of the liquid used to cool the decrusting knives has to be removed. The next process is the most stressful. The thinning of the ingot begins. The aluminium block is crushed by the hot mill rollers. Even the rollers operate at temperatures between 455 and 540 degrees centigrade. Firstly, the pressure on the ingot must be verified. If too great, it could split this block, and they'd have to start again. The heat is so intense that the ingot risks sticking to the mill's roller. A lubricant is used to prevent this that's 95% water and 5% oil. Starting from a thickness of 45 centimeters, the ingot becomes increasingly thinner with each pass-through. The aluminium slab may have to pass through the crushing rollers 16 times before the right thickness can be achieved. The ingot now measures 7 centimeters in thickness, but still it has to get down to just half a centimeter. Now the ingot is 5 centimeters thick and measures over 9 meters in length. The plate takes its last journey over a conveyor to the final milling stages. Sufficiently thin to proceed with spooling, the plates wrap themselves around to make perfect cylinders. They're then sent to the cold rolling mill, where they're reduced even further. Now comes the most delicate stage. The aluminium sheets have become so thin, they risk being broken by the tension needed for the cold rolling. So the sheet is doubled to avoid this breakage. One last alteration in the mill settings will create a sheet with exactly the thickness required for kitchen-grade aluminium foil. To finalize the process, the edges of the foil sheet which have become damaged and crinkled are removed with a knife that slices a 1 centimeter thin strip. The roll is cut to the desired width. And one huge ingot has produced foil measuring 12.7 kilometers in length.